the fifth part of the unit 1, that is the gating systems. We are coming to discussion of the gating system, and end of this lecture student will able to learn the principle of the gating system, gating ratio and design of the gating systems. That things will learn in that particular section, gating system. What are the gating system? Gating system means that refers the all passageway, means the network through which we send the molten metal to the particular mold cavity, network of the channel. Okay, term gating system means all passageway through which we passes the molten metal to that particular mold cavity. What are the units of that particular gating system? First, pouring basin, then sprue, main parts of the gating system, then runner, fourth is gates, and fifth is risers. That are the fifth units of that particular gating system. That is the main parts of the gating system. Now, that is the one schematic diagram of that particular gating system. We are seeing that is the pouring cup through which we pour the molten metal, and in that portion, that is the sprue. That part is sprue. Okay, and that is the sprue oil in that particular portion. After that, the part is runner. That is the runner. Okay, and in that particular portion, that is called gate, means entrance of the molten metal, and that is the casting, means particular mold cavity we have generated, means after that particular shape we have required after casting, and that portion is the top riser, means extra metal we have reserved in that particular portion, means that act as a reservoir, means when compensation takes place, so extra metal coming from that particular riser portion, that part is the top riser. Now, to any gating system design should aim provided a defect free casting, means we have generated any type of product that will be defect free casting. So in that cases, what will be the consideration? So what will be the requirements to get the particular defect free casting? So for getting the defect free casting, so what are the requirements to that particular gating system? First one, gating system avoid the right angle changes in particular directions, means sharp corner, that type of sharp corners, means that is the rectangle, that type of you avoided that type of shape, means avoid the sudden or right angle changes in directions. Otherwise, what happens when molten metal comes through this system, it will affect that particular portion, and due to flow of that particular molten metal to that corner, it will affect that particular portion. Then again it will create the turbulence, means the inside part of that particular gating system that will be affected due to providing that type of right angles or sudden changes in direction. Another, gating system must be fill up the mold cavity properly before freezing. Before taking the solidification, it will take the particular fill up of the mold cavity, because means it maintain the particular pouring temperature. Otherwise, it does not maintain the pouring temperature, it will come to that particular, if we consider that is the mold cavity. Okay, say the molten metal comes, means it does not maintain the particular pouring temperature, means it will take solidification before coming to that particular total place. Shape will not generated, means it will come and it taking the freezing to that particular portion, and so in that particular portion does not fill up. So due to that thing, means before freezing the molten metal take the whole cavity, take the shape of the whole cavity, means it is the particular pouring temperature required. Third is, metal will be flow to the particular mold cavity smooth way, means uniform flow is required, means laminar flow will be required. If flow is turbulence flow, so in that cases the inside portion of the particular mold cavity and also gating system may be eroded. Unwanted metals. Always you remove the unwanted metals. Unwanted metals means impurities, slag, dross or other type of impurities. You remove that portion. So for removal of that portion, we have used the strainer to that particular pouring basin. Okay. So otherwise, that type of impurities will be added to the particular product, casting product. And fifth one, metal will be entry to that particular mold cavity in such a way, means the air will be removed from that particular portions. Means you always avoid the aspiration effect, and also you avoid the gas porosity. Means some passage is required, means it will remove the gases from that particular mold cavity. Otherwise, the gas, if it present inside the product, so the strength and shape of the particular product is not good. So proper functioning of the gating system, the following factors, means proper functioning of the gating system, the following points must be controlled. What are the points? Means type of pouring equipment such as ladles and pouring vessels. So that type of equipments also very good equipments. Okay, ladles, from the ladles we have poured the molten metal to that particular pouring basin or pouring cup. Another, always you maintain the pouring temperature. So due to maintaining the pouring temperature, the molten metal maintain the fluidity properties, and due to fluidity property, the molten metal always easily flow to that particular mold cavity and fill up the total entire portion of that particular mold cavity. Means fluidity of the molten metal, it is required. Another, rate of liquid metal pouring, means higher flow of the molten metal sometimes eroded the inside surface of the gating system and also mold cavity. So always you, and lower flow rate sometimes, lower flow rate of the molten metal sometimes it will take freezing before fill up of the total entire surface. So always you maintain the optimum flow rate to that particular molten metal. Okay. Another, type and size of the sprue, means it is also its size of the sprue, that type of shape, means conical type shape also you flow, means you does not take other types of shape. Means in that cases the flow of the molten metal does not control properly, and also it will affect the total gating system also. And another, type and size of the runner portion also, that is will be horizontal shape, that also depends upon the flow of the molten metal. Another, size, number, location of the gates connecting to the runners, that also another important issue. Means flow of the molten metal to that particular mold cavity, that controlled by the gates, that gates will be connected to the runners. Position of the mold during pouring and solidification, position of the mold, that is also important. Means position of the mold, that will be vertical or horizontal or inclined, that is also affects to that particular gating system, proper functioning of the gating systems also. Now that are the some shape of the particular pouring basin, means always you follow that type of shape, always you follow that type of shape, pouring basin shapes. So that will be typical shape of the particular pouring basin. So you always maintain that type of pouring basin shapes. So you does not follow the other types of shapes. Other types of shape may be affected when we pouring the molten metal to that particular system, gating system. Now, a pouring basin makes it easier for the ladle or crucible operator to direct the flow of the molten metal. Means the above, means already I have seen the shape of the pouring basin. So if you maintain that particular shape of the pouring basin, when we pour the molten metal from the ladle, so it will flow properly through the gating system. Another, maintain the required rate of the liquid metal, and also through that particular using pouring basin, the metal flow also will be good. Another, that type of shape also reduces the turbulence of the flow of the molten metal. Another, easily we can separating the impurities, means dross or slag, any type of impurities, easily we can remove. Means if we use that type of pouring basin, so here we use any strainer. If we use any type of strainer, so in that portion we remove the easily from that particular portion. Using the strainer we remove the impurities from that particular portion. So the molten metal goes through that particular section, mold cavity, and defect free product will be generated. Now that are the some shape of the pouring basin, different shape of the pouring basin. We have used typical some shape of the pouring basin. So here in that particular portion we have used the strainer, means it will for removal of the impurities from the particular portions. And if we use some dam means due to use of that dam we control the flow of the turbulence, we control the flow of the molten metal. So when we pouring the molten metal here, it will obstruct in that particular portion, and means it does not create the turbulence flow. Okay, means due to position of that dam, the flow maintains the laminar flow. If the pouring basin are made large, so dross slag formation will tend to float on the surface, and due to presence of that particular impurity, sometimes it will be stopped the flow of the molten metal through the sprue system and also runner system, and also does not also sometimes stopped the through getting system. So always you remove the dross and slag portion. Another, so always you fill up quickly without overflowing and may act as a reservoir. So always you avoid the overflowing of the molten metal. So you try to flow the molten metal smoothly, means to maintain the laminar flow. Easily it will goes to the mold cavity and take the fill up of the entire surface of that particular metal mold cavity. So the product will be generated in very good manner. Otherwise, if are taking very high rate flow, sometimes erosion will be takes place to that particular getting system. The generated product also will be not good. Sprue. Sprue means what happens, that is the vertical section of the particular getting system. Means a sprue feeds the metal to runner which is coming from pouring basin. Okay, means that is the middle part of the pouring basin to basin, and means it will connected to the pouring cup and connected to the pouring runner. Okay, and the casting through gates. Okay. A sprue, generally shape of the sprue is the stepper type shape. Okay, bigger end it will be connected to the pouring basin and top to receive the liquid metal, and the smaller end will be connected to the particular runner portion. Means it will take that type of shape. It will take that type of cone type shape. Means stepper type shape provided to the particular sprue system. Gates. So gates means it controls the flow of pouring metal to the mold cavity. Okay, it controls the flow of the molten metal to the mold cavity. Means a gate is a channel which connects the runner with the mold cavity. Means that is a channel. It will, means if it is a runner, if it is a mold cavity, so it will connect that portion. It will connect that portion. Means it will act as a gate. Okay. The small gate used for a casting will solidify slowly. Means if gate shape is less, so it will flow of the molten metal controlled. Means it will the flow of the molten metal it is a very less. So and all the shapes of the mold cavity it is fill up easily. Okay. Otherwise, if does not fill up the proper whole shape of the mold cavity, the total shape of that particular portion will not produced. Means total entire product will not produced. So gates also control the flow of the molten metal to the particular mold cavity. What are the different types of gate? Top gate, bottom gate and parting line gate. That are the three gates are main gate. So in case of top gate, we are seeing that the top gate is sometimes also called as drop gate, because the molten metal just drops on the sand in the bottom of the mold. Means through the top gate the molten metal just drop down to the lower portion of the mold cavity. Okay. So generation of the favorable temperature gradients to enable directional solidification. So means if we maintain the pouring temperature to that particular molten metal, it will control the flow of the molten metal to the particular mold cavity easily. Okay. Another, that is the some example of the top gate, that are the some top gate of that particular picture. Okay, it will shows the some particular top gate of the particular casting process. If the molten metal coming through that particular gate, it will directly come to the mold cavity at the bottom portion. It will come to the particular bottom portion. What are the disadvantages? Sometimes dropping of liquid metal to the particular bottom portion of the mold cavity sometimes eroded. Dropping of the liquid metal stream sometimes erodes the mold cavity. Okay, means turbulence dropping of the molten metal sometimes erodes the mold surface. Erodes the mold surface. So we avoided the turbulence. Lot of turbulence means flow of the molten metal through the top gate. Always avoid the turbulence effect. Always remove the turbulence effect. Bottom gate means that gate will be made to the particular drag portion. That bottom gate, top gate will be provided to the cope portion, means that is the upper part of the casting, and lower part of the casting, that is called drag. Means bottom gate will be provided to the drag portion. Okay. So in case of it will flow rapidly through the bottom gate, so mold cavity rises steadily, means through the top gate molten metal comings and fill up the bottom cavity of that particular mold. So then it will fill up again, the bottom gate, the molten metal will fill up, through the bottom gate the molten metal will be flow and taking the total shape of the mold cavity. Okay, and then it will fill up the upper surface of that particular mold cavity. Means top gate control the flow of the lower portion of the mold cavity, bottom gate maintain the flow of the molten metal to the upper portion of the mold cavity, and bottom gate produces good casting products also. Means it does not create any type of turbulence effect. Means here we have seen that. So if we consider that is the cavity, so in that cases that is the bottom gate, means that portion is the lower part of the drag portion. What are the disadvantages? Means in the bottom gate liquid metal enters to the mold cavity at the bottom. If freezing takes place at the bottom, it could choke of the metal flow before the mold is full. Means in that cases does not take any freezing when coming to the mold cavity of the molten metal. So always we avoided the freezing of the molten metal. So it will flow through the bottom gates. Means the fluidity of the molten metal always you maintain. Otherwise it will take the freezing to that particular mold cavity. Means sometimes due to freezing to the mold cavity, the total entire surface of the particular mold cavity, means inside surface of the mold cavity does not fill up properly. So always you maintain the flow of the mold cavity, means it will take the total shape of the mold cavity. So the product will be defect free product. A bottom gate creates unfavorable temperature gradient and makes it difficult to achieve directional solidification. If does not maintain the proper pouring temperature due to proper due to improper maintaining of the temperature, it will does not take the entire shape of that particular mole cavity. So always you maintain the proper temperature, proper pouring temperature. It will help to take the fill up of the particular cavity surface. Means it will flow to that particular mole cavity and take the whole surface, and the proper defect free casting product will be produced. Parting line gate. So in that cases, some portions means middle portion, that is if we are taking that is the molding box, so middle portion is the parting line. Sometimes gates will be above the parting, some portion of the gates above the parting line, and some portion of the gates will be below the parting line. Okay, so that gates will be vary across the parting line. Okay, means middle or side patterning gating system combines the characteristics top and bottom gating system. Means upper part of the top gate, it will just up or above the parting line, and bottom gate just below the parting line. Okay, means it will maintain above the parting line. That parting line gets maintained along the parting line. In this technique, gate is provided along the parting line such that some portion of the mole cavity just above the parting line and some portion of the gate will be below the parting line. The cavity below the parting line will be filled up by the assuming top gating. Means when flow of the molten metal to the particular mole cavity, means molten metal flow through the top gate and it will come the lower portion, come to the lower portion of the mole cavity. If that is the mole cavity, it will come to the lower portion of the mole cavity through the bottom gate, through the top gate. Through the bottom gate, mole cavity fill up the upper portion of that particular mole cavity. Design of the gating system. What are the criteria for getting the, for providing the good gating system? What are the criteria? To fill up the mole cavity without breaking the flow of the liquid metal, means always you avoid the turbulence. When you pouring the molten metal to the particular mole cavity, always you avoid the turbulence, and also you taken care about the flow of the molten metal, means it does not affect the mole cavity. To avoid the erosion of the mole cavity, means when you pouring the molten metal to that gating systems, always you taken care about that flow of the molten metals, means due to creation of the turbulence, sometimes inside surface of the molten, inside surface of the gating system may be eroded. Also you taken care about that thing. Third, to minimize the turbulence and dross formation. Turbulence flow may be eroded the inside portions. Always you maintain the laminar flow, and also remove the dross, means impurities from that particular molten metal using strainer to the particular basin portion. If you remove the any impurities, dross or slag from the particular molten metal, does not any defect will be created to that particular casting product. Another, to prevent aspiration effect, means to prevent aspiration, means any gases or any air will be entrapped to that particular molten metal, so that will be product will be defect product. So remove that particular portion. So always you use some devices for removing the gases from that particular portion. Okay. Another, to obtain favorable temperature, always you maintain the pouring temperature to fill up the total mole cavity. Otherwise, it does not fill up the total mole cavity shape. So cold shot, that type of defect will be generated particular casting product. How we design the type of flow? When, means the flow of the molten metal, how we design that thing, means flow is laminar or flow is turbulent, how we can decide? So for getting the type of flow, we use the Reynolds number. We use the Reynolds number. Re equals to rho Vd by mu. Rho means density, V means flow of liquid metal, and D is the diameter of the gating system. Means a runner, means that is maintain the cylindrical type shape or circular type shape, and nu means viscosity, that is the dynamic viscosity. Based on that formula, finally we have find out the Reynolds number. So Reynolds number less than 2000, it will the laminar flow or it will maintain the smooth flow. Okay, and RE Reynolds number greater than 4000, it will maintain the turbulence flow, and in between 2000 and 4000, that flow is the transition flow. Okay, based on that we control through gate and runner design. Means based on the flow of the liquid metal, based on that we design the gate and runner of the gating system. Now metal, how we measure the flow rate and velocity, how we measure the flow rate and velocity to that particular flow of the liquid metal. So using that laws of fluid dynamics, as per laws of fluid dynamics, we use the law of continuity equation. We use the law of continuity equation, means A1, Q is the flow rate. We know Q equals to flow rate. Q equals to A1 V1 equals to A2 V2. Means if we flow different sections, so flow rate will be, we can write Q equals to, means that is the law of continuity equation, Q equals to A1 V1 equals to A2 V2. Q means volume of the flow rate, and A is the cross sectional area of the flow passage. V equals to linear velocity of the flow. Linear velocity of the flow. As per Bernoulli's equation, we find out the flow velocity. As per Bernoulli's, using Bernoulli's equation, we measure the flow velocity of the pouring molten metal. So as per assumptions in Bernoulli's equations, flow will be steady state. Means the flow characteristics does not change with time. That is the steady state. Incompressible. Incompressible means here density will be constant to that particular liquid. Inviscid means to that particular fluid no viscosity is there. Okay. So as per, if we taking two sections to that particular flow channel, so formula will be P1 by rho g and V1 square by 2g H1, that is the section 1. Okay, and section 2 P2 by rho g V2 square by 2g and plus H2 as per Bernoulli's equation. So P means, here P means pressure, rho means density of that particular liquid, g means acceleration due to gravity, okay, V means flow, means velocity of the liquid metal, and H1 is the height, elevation height to section 1 and elevation height to section 2. Means height above the datum line. If we are taking datum line, so we consider the height. Okay, height considered in section 1 if it is section 1 and if it is section 2, that is called datum line. The height will be calculated from the datum line, that is called elevation height. Design criteria of the pouring basin. So in that cases what we do, now in that cases the pouring basin must be designed such that way the pouring basin maintain the proper uniform flow of the molten metal. It maintain the uniform flow of the molten metal. So in that cases that type of uniform flow will be achieved using the use of strainer core. Using strainer core we remove the impurities, slag, dross, that type of unwanted materials, and use also dam to make steady flow. Means you use the dam. Due to presence of dam to that particular basin, it will maintain the smooth flow. Use of screw plug. So due to use of screw plug, so it will throw the molten metal through the runner at the same times. Means using runner, the flow of the molten metal in every pattern, getting every patterns or every mold cavity at a time, the molten metal of the flow of the molten metal control using sprue plug to the different mold cavity. At a time, we maintain the flow of the molten metal to different mold cavity. So always it will be easy and convenient to fill the pouring basin. Means always we fill up the pouring basin using molten metal easy. It will be easy and convenient. Okay. Design of the sprue. Always you maintain liquid metal passes down the sprue, it loses its pressure head but gains velocity. Means if we pouring the molten metal through that particular sprue, it loses pressure head but gains velocity. So always you avoid that type of shape. Always you avoid that type of shape of the sprue. Means does not take that type of shape. Always you take that type of shape. Taper type shape, conical type shape always you maintain. That is the main shape of that particular sprue system. Means that type of shape it will be avoid the turbulence flow to that particular molten metal, and also it will control the flow of the molten metal smoothly. Means it maintain the uniform flow or laminar flow to using that type of sprue system. Means that is the conical type, or maybe it is called taper type sprue system. So for getting or for calculation of the flow velocity of the liquid metal, we are taking that type of shape. Means if it is called, that is called pouring basin. That is called pouring basin. Okay. Means that is the datum line section 1, and if in case of that is the lower part of that pouring basin, means from that particular portion it will start the sprue. In case of sprue system, the section 2, that is the upper part and lower part of that particular sprue, in that system section 3, that is the lower part of the sprue. So based on that we calculate the velocity of that particular system. So section 1, free surface of the metal, that is the free surface of the metal, means we consider that is the datum surface. Okay. 2, that is the sprue top of the top portion of the sprue, and section 3, that is the lower portion of the sprue. So based on that, entire mold is at atmospheric pressure. Means no point below atmospheric. Means always we maintain the atmospheric pressure in that particular system. And metal pouring basin, when we pouring the molten metal to that particular basin, it maintain the zero velocity. No velocity present to that particular pouring basin. So using that two sections, we know the formula, simple formula of mass flow rate, that is the rho AV constant. Rho means density of the liquid metal, A means area, the passage area through which the molten metal will be flow, and V means that is the velocity. So using that formula we can measure the mass flow rate. So applying continuity equation, already we know continuity equation A1 V1 equals to A2 V2. Okay, here section we consider the section 2 and section 3, means that is the top surface of the sprue, and below surface means bottom surface of the sprue, that is the section 3, and section 1 already have told, that is the datum line, means here that is the free surface of the metal. So we consider that section 2 and section 3. Section 3, based on that picture, now we can write the continuity equation A2 V2 equals to A3 V3. So using that equation, now we can write A2 or A2 by A3 equals to V3 by V2. And also we know the theoretical velocity formula, V equals to root over 2gh. G means acceleration due to gravity, h means height of, that means elevation height. Okay, so based on that particular theoretical velocity formula, now we can write V3 equals to 2ght. 2ght means that is the elevation height. Okay, that is the elevation head. From section 3, elevation is equals to HT, and from section 2, that is the top surface of the sprue, that elevation head will be HC. And now we can write V3 equals to root over 2GHT, and by, in case of V2 means for section 2, that 2GHC. Now after that G will be cut and 2 cut. Then finally we have got HT by HC, means A2 by A3 equals to V3 by V2 equals to, finally we have got HT by HC, root over HT by HC. And now, or we can write root over HT by, or we can write root over HT by HC equals to A2 by A3. Now square both sides. Finally we have got HT by HC equals to A2 by A3 whole square. Means due to square, the square will be removed, and finally we have got HT by HC equals to A2 by A3 whole square. And using that equation, that will be meaning of that will be parabola equation. It will maintain the parabola equations, mean actual shape of the sprue will be parabola type, but in practically we remove that thing. Generally we avoid the manufacturing difficulty, means parabola type shape generation, that is very difficult. So due to avoiding that thing in manufacturing easy way, so we taking the taper type cylinder surface, means that type of surface we have taking, that type of surface we follow, means conical type shape or sprue type shape, conical type shape or taper type shape we are taking in case of sprue system and to the gating system. In case of taper type shape of the sprue, it will reduces the flow of the turbulence, means it maintain the smooth flow, it maintain the uniform flow, means maintain the laminar flow. Due to laminar flow of the liquid molten metal, so it does not erode the inside surface of the gating system. Okay, and that's why we follow the taper type sprue shape. Okay, and also it will reduces the flow of the molten metals also. The area to the sprue exit controls, means the sprue shape, that is the area is reduces, means that is called choke area, that is the choke, means smallest area of that particular system, that is called choke area. Okay, it will maintain, that choked area maintain the flow rate of the liquid metal into the mold cavity, and also velocity, it maintain the flow rate, maintain the velocity of that flow liquid metal, and also it will control flow pouring time also. It will also maintain the pouring time, means maintain the or control the pouring time also. Okay, so choke means already I have told, choke is the part of the gating system which has the smallest cross section area of that two particular gating system. Means in a free gating system, sprue serves as a choke, means smallest part of that particular gating system, it will act as a choke. So due to that choke area to that particular gating system, it reduces the erosion to the inside surface of the gating system. Okay, and also it will remove the air aspiration effect, means if trapping any type of gases to that particular molten metal, sometimes some gas porosity, gas bubbles will be remaining to that particular mold cavity, and due to that gas porosity problems, the product quality will be deteriorated. So removal that gas product, also we avoiding the gas porosity problems using that type of sprue. Now in a choke system, gate serves as a choke, already I have told. So that creates, means due to choke system, that is the smallest part of that particular sprue system, so it will maintain, if smallest area, due to smallest area, it will creates the pressurized system, means here molten metal comes and it creates the pressure, and through that particular pressure the molten metal sometimes creates the turbulence. Okay, and due to turbulence, sometimes inside portion of the gating system may be eroded. So always we taken care about that thing also. Means due to choked area, sometimes pressurized system will be created. Due to high metal velocity and turbulence, this system experiences oxidation erosion. Means due to choked area, maybe inside portion will be eroded because turbulence will be created to that choke area. And another thing, the exit, if it is least, known as choke area, means smallest portion of that particular gating system, that is called choke area. And pouring time, high pouring rates, if high pouring of that molten metal to the gating system leads to erosion, rough surface, excessive shrinkage. And low pouring rates, sometimes what happens, that does not fill up the proper mold cavity. So due to does not fill up the mold cavity, that type of cold shut problems will be created. So always you maintain optimum pouring rate. Always you maintain the optimum pouring rate or pouring time for casting of the molten metal. That is the very important thing in case of pouring time. So light metal, pouring time of light metal alloy, unlike steel, aluminum, magnesium alloy, that are maintained at slow rate. Okay, and this is the necessary to avoid in case of steel, aluminum, magnesium are poured at a slow rate. So this is necessary to avoid the turbulence, and aspiration effect to that particular casting system. Okay, so for that metal, slow pouring rates is required to avoid the turbulence and aspiration effect. Means does not any gas porosity problems will be generated to that particular system. So in case of design, runner and gate system, so in that cases abrupt changes in sections, means any type of corner shapes, means abrupt changes in directions, means sharp corner type, right angle type, or avoid that type of things, because due to that thing the obstacle will be created to the flow of the molten metal, and due to that thing the molten metal does not flow to that particular mold cavity. Okay, and due to improper flow of the mold cavity does not take the proper shape to that particular mold cavity also. So avoided abrupt changes in sections. Okay, a suitable relationship is required in case of cross sectional area of the sprue and in case of runner and its gates. Cross sectional area of the sprue, runner and gates, that relations also required in case of very good gating systems. So if we see the in case of gating ratio, what is gating ratio? Gating ratio is denoted by A is to B is to C. In case of A, that is the cross sectional area of the sprue, B means cross sectional area of the runner, C means cross sectional area of the gate. That is called gating ratio. So total cross sectional decreases towards the mold cavity. This provides by choke effect. Means due to choke effect creates the pressurized gating system. If you total cross sectional area increases, means you avoid the choke effect, so it will passage remain incompletely fill up. Means if we create the choke system, so it will create the pressure, and due to pressure the molten metal gets to that particular mold cavity, due to pressure, because here choke system will be created. If you remove that choke system, that does not create the pressure, maybe sometimes the molten metal does not fill up the total mold cavity, means cold shut type problems will be occurred to that particular molten metal. So in that cases that will flow the unpressurized system. Means total cross sectional area increases, so passage remain incompletely filled up. It is called unpressurized system. Due to presence of choke effect, that maintain the pressurized system, and when you increases the total cross sectional area, it will maintain the unpressurized system. So what will be the difference between them? In case of pressurized gating system, the casting ratio may be order of 3:2:1. 3 means area of the sprue, 2 means area of the runner, and 1 means area of the gate. means that is the ratio of, that is the follow the getting ratio in case of pressurized getting system. 1:3:2 it will maintain that getting ratio in case of unpressurized getting system. Air of aspiration effect is minimum due to presence of choked effect. It will aspiration effect is minimum. In case of here aspiration effect is more. And volume of flow of liquid from the choked area, that will the almost equal. But in case of volume of flow liquid metal from every ingot, that will be different, because the flow of the liquid metal through the sprue system, that is the more area is there, more molten metal will be flow. So flow of the molten metal through the ingot, it is different. They are smaller in volume because the area of that particular choked area, that is the less, and so due to that thing flow rate also controlled. So due to that thing casting yield will be higher. And in case of that, the larger volume, because they involve large runners and large gates. So due to that thing, the cast yield is reduced. Here cast yield is higher, here cast yield is reduced. Velocity is high due to presence of choke, means smaller cross sectional area will be present to that particular gate, to particular sprue system. So due to choked area, that thing the velocity will be high. So due to that thing, sometimes turbulence will be awkward. And here velocity is low because no choked area is there. So here turbulence is not created, means effect of turbulence is reduced. What is the streamlining of the gating system? Means it includes removing the sharp corners or junction by giving a generous radius. Means if you any gating system you create, that is the right angle type shape. So it will provide a streamlining, means you avoided the corners, means that type of shapes will be generated. Means you provide some radius. So in that cases, streamlining means flow of the molten metal will be very good. Another, tapering the sprue, means you provide that type of shape. Tapering type shape means it will, the flow of the molten metal will be very good. Another thing, radius and sprue entrance and exit. Sprue entrance means you provide the radius. Radius will be provided in that particular portion, and also providing radius to that particular sections. Means here flow of the molten metal will be smooth and laminar. Means always you avoid that type of shape. You always avoid that type of shape. Always you maintain the flow of the molten metal or shape of the sprue, that type of shape. Means you provide some radius. What happens in case A6, that picture shows that turbulence resulting from sharp corners. Due to sharp corners resulting, the turbulence will be created, and due to that shape, what happens? Now metal damage resulting from a sharp corner. Metal damage means here that surface may be damaged, may be eroded. Okay, and in that cases no turbulence will be no erosion will be takes place due to that particular shape. What are the advantages in case of streamlining? Now, no metal turbulences will be created. No turbulence will be created, and also no aspiration effect will be created. Another, mold erosion also not created. No dross will be added to that particular molten metal. And fourth, last one, the casting product, the generated solidified product must be clean and sound product will be generated. And end of this lecture, we have seen that we have learned, student will learn the principle of the gating system, gating ratio and design of the gating system. They have learned from that particular lecture. Normal gating system, that is the picture of the gating system, that is the pouring cup, and that is the sprue, and that is the sprue base oil, and that is the runner. Okay, and that is the gate, and that is the casting, means mold cavity. Okay, and that is the different gate is there, and that is the riser, which is acting as a reservoir of the molten metal. First part is the pouring cup, through which we pour the molten metal, means molten metal we are taken from the ladle. That is the pouring cup. That is the sprue which is connected to the pouring basin, means pouring cup. That is the vertical portion. Now the end part of the sprue base oil is there, because due to presence of sprue base oil, it will for a small time the molten metal will be stored here, and from that sprue base oil then the molten metal goes through the runner. If we does not take that sprue base oil, it will create the turbulence. Initially here stored the molten metal, then it will again flow through that particular runner, and that are the gate. That gate will be connected to that particular casting, means mold cavity, means using sometimes sprue plug through that particular gate at a same time molten metal will be flow to that particular mold cavity using sprue plug. That is the gate, and that is the riser, means extra metal stored in that particular riser system. After solidification, some shrinkage will be created, means and due to shrinkage of that casting product, for fill up of that shrinkage portion or some allowances portion, some extra metal coming from that particular riser and compensate that particular allowances, and finally the product, means as per required product will be generated by that particular casting process. That is the riser. That are the function of the different parts. That is the total parts of the gating systems.